Welcome back, everyone. I hope you guys had a great Christmas vacation and got to do a lot of fun things, hanging out, being with family, whatever it is that you did. I was able to go to Michigan and enjoy some time skiing and with family for a week, so that was fun. Anyway, we are going to be starting a new unit, Unit 5, which is polynomials. Today we're going to be classifying, adding, and subtracting polynomials. This is a really important unit, so you must pay attention to all of the things that I tell you because this unit is going to lead to the next unit and it's going to continue for the rest of the school year. So this is really important that we get all the basics down before we continue to move on. So our goal for today is I can classify, add, and subtract polynomials. Hopefully you guys all did your reflection. That was the first thing it needed to do. You are getting some points for that, so make sure that you complete it if you haven't already. That was the first thing in the Canvas module for you to do today. All right, we're going to look at the vocabulary. The vocabulary is very important in this unit. When we're classifying, you're going to have to know what all of these mean and how to put them in context of the problem. So a polynomial, that is an expression consisting of constants, variables, and or exponents that are combined using mathematical operations. There are different types of polynomials. We are going to be looking at the monomial, binomial, and trinomial. A monomial is a number, variable, or product of a number and a variable. A polynomial that is a monomial only has one term. So a one-term polynomial is called a monomial. An example would look like this: 2x squared y. Or another example could just be a constant, -2. So you can see different ones that are put together. Even though the 2x squared y has variables with it, it's still only one term because it's the product of all of those things multiplied together. All right. A binomial is a polynomial with two terms. Bi means two, so it's two terms. An example of that is 5x plus 2. If you notice, this is separated by a plus or a minus. So 5x plus 2, 5x is one term and 2 is the other term. So that is a little bit different than this one. This one does not have a plus or a minus in between. It is all multiplied together to be one monomial. The binomial has a plus or minus in between. All right, trinomial. Of course, tri means 3, so that's a polynomial with 3 terms separated by a plus or a minus. So an example of a trinomial would be x squared plus 5x minus 2. There's 3 terms. X squared is a term, 5x is a term, and -2 is a term. So each term is separated by a plus or a minus sign. All right. Anything that has more than 3 terms, we just call a polynomial. We call it by its term. So if it had 4 terms, for instance, say, I'll just write it up here. x squared plus 3x. Actually, let's do this. Oops. Let's do x cubed plus 3x squared minus 2x plus 4. There's 4 terms, and we just call that a fourth term polynomial. And you can write that anywhere on your paper if you can find room. So anything more than 3 terms is called by its term. So if this had 5 terms, it would be a 5th term polynomial. If it had 6 terms, it would be a 6th term polynomial. That is how we are classifying it. But if it has 1, 2, or 3 terms, you must call it by a monomial, binomial, or trinomial. All right, the next thing we're going to look at is the degree. The degree of a polynomial is the highest degree of the individual terms of a polynomial. So the highest or greatest, you could say highest or greatest degree of the individual terms of a polynomial. So if I look at this term right here, okay, we have to always put our polynomials in standard form, which is what we're going to talk about next. But the degree of the polynomial is the highest degree. We look at the biggest exponent. So this is the biggest exponent. Okay. All right, standard form. When the exponents of the terms decrease from left to right. That means we write our highest exponent first, and then whatever term has the next exponent, and then the next lowest exponent, and then the constants are always last. Okay? And we'll talk about that in a minute. The leading coefficient is the number of the first term when the polynomial is written in standard form. Okay? So if we look at the polynomial below, 2x cubed plus x squared minus 5x plus 12, that is already in standard form because the highest exponent is first, the 2 is the next, exponent of this one is a 1, and this is a constant. So it's already written in standard form. All of the polynomials that we write must be written that way, where the highest exponent is always first. Okay? Now, the 2, this 2 right here, just the 2, is the leading coefficient. And if we look back at the definition, the leading coefficient is the number of the first term when the polynomial is in standard form. Since 2x cubed plus x squared minus 5x plus 12 is already in standard form, 2 is the leading coefficient. It's always that first number. All right. The 3, that is your degree. So this is the degree because it's the highest exponent. Okay, so this has a degree of 3. So when we classify, we would say the leading coefficient is 2. It has a degree of 3. The last number, that 12, is a constant. Constants are always last. Okay? And then if we have more than one variable, like we did up here, if we look at this, if we have more than one variable, then we write our variables in order alphabetically. Okay? So, can put this up here. Variables are written alphabetically. Okay. All right, so we're going to do a little bit of practice. We're going to complete the table below. Now my number 1 is going to look different than your number 1. So you can cross off your number 1 and write in my number 1. Your number 1 should say x squared plus x cubed minus 10x. Or how about let's just put a line through it and we can do both. So yours will have yours on top. So let's just make a nice little line. And we're going to write both. The more practice we have, the better. All right, so yours says x squared plus x to the third minus 10x. Okay, we're going to do yours first since it's already on top. Okay, so looking at this, x squared plus x cubed minus 10x. Is that in standard form? Remember, for it to be in standard form, the highest exponent has to go first. So this one is not in standard form, so we need to put it in standard form, which means I'm going to write the x cubed first, because that's the highest exponent, plus x squared, because that's the next highest exponent, and then minus 10x. Now that is in standard form. The degree is the highest exponent. So this is degree 3. And the leading coefficient is always the number in the front. Since this doesn't have a number, we assume the number is 1. So the leading coefficient would be a 1. And the type of polynomial, since it has 3 terms, this is going to be a trinomial. All right, let's try mine. So write mine that's on my paper underneath the one that you just did in the same block. Okay, we're going to do this one next. It's not in standard form. Remember, the exponent of this one is a 1 since it doesn't have anything. So we're going to put it in standard form. The x squared would have to go first, minus x, and then minus 10. Remember, constants are always last. Now it's in standard form. The degree is always the highest exponent, which is going to be the first term once it's in standard form. So that's degree 2. The leading coefficient is going to be 1 again, because it's doesn't have a number in front, so 1 is going to be the leading coefficient. And it is also a trinomial because it has 3 terms. All right, I want you to take a couple minutes and pause the video, and I want you to try these 3 right here. Okay, the last one's a little bit tricky, so I want to do that one together. But pause the video and finish those 3. See if you can write those in the table, and then check your answer with mine in just a moment. So go ahead and pause now, do the work for those 3, and come back and check your work. Negative 3x to the 4th is already in standard form, so you don't have to do anything else with it. Degree 4, leading coefficient is negative 3, and that is just a monomial. Has 1 term. This one, highest coefficient is the 3, so negative 2x to the third. The next one is the 2, so plus 5x squared, plus 3x, and plus 7. The leading coefficient is 3. The degree is 3. The leading coefficient is negative 2. And this is just a fourth term polynomial. Remember, anything more than 3 terms, we name it by the term, and it's just a polynomial. All right, hopefully you all did well on those 3. Now we're going to do this one right here. This one is the tricky one. This is a monomial. Okay, we first look to see, are the letters in alphabetical order? It doesn't matter what the size of the exponents are. It just matters if the letters are in alphabetical order when it's all one term. It's not separated by any pluses or minuses. So since they are in alphabetical order, this is already in standard form. 6x, y squared, z to the fourth. Already in standard form. Now, if this was switched and looked like this, we would have to switch those to make it in standard form. So it just depends on what it looks like, on where the variables are, if they're in alphabetical order or not. It doesn't matter the numbers of the exponents. All right, so this one's in standard form. The degree is the different part. So this one is where it's tricky. The degree for these, we add up. So add all exponents. Okay, so the degree is we have to add all the exponents. So we have a 1, a 2, and a 4. So this is a degree 7. So this is a degree of 7. We still have a leading coefficient is the same. That's your 6, the number up front. And this is just a monomial. It's just one term because it doesn't have any pluses or minuses in between the letters and numbers. Okay, so that is how we classify. This is going to be a big part of your test because you're going to have several of these that you're going to need to classify. So make sure that you know how to do them. Make sure you know how to put it in standard form. Make sure you know what the degree means, the leading coefficient, and the type of polynomial. This is very simple work. It's just memorizing all the information. Okay? All right, adding polynomials. So this is the next part. To add polynomials, you add like terms, just like we always learned. Okay, this isn't anything new. It's just putting stuff together just like we know how to do. And we always must put our answer in standard form. So we're first going to add the polynomials. We're going to find the sum and write our answer in standard form. They're usually going to be in parentheses, so each grouping is going to be in parentheses. This is one binomial plus another binomial. So we have a binomial plus a binomial. We're going to drop parentheses and rewrite this as 1. Okay, so now we have just one big polynomial that we're going to add together. Now I'm going to first look for my highest degree. My highest degree is 4, so I'm going to find all of the ones that have an exponent of 4. And I'm going to do the operation that it says. This is 8x to the fourth plus 2x to the fourth. So 8 plus 2 is going to give me 10x to the fourth. You do not add exponents. We are just adding the coefficients, the numbers in the front. So now we took care of that. So those are gone. And now I need to add negative 3x plus 4x. Those are like terms. So I'm going to put them together and I get plus x. So since I started with the highest exponent and I worked my way down, It's already in standard form, so my final answer is 10x to the fourth plus x. Okay, now we still have a binomial. When we add two binomials together, we got a binomial. It's not always going to work that way, but just so happened that it did this time because both of the like terms were exactly the same. It won't always be that way if you have different like terms. All right, let's try number 2. We're going to rewrite the problem dropping the parentheses. And this is a plus a negative, so I'm just going to write it as minus 8x squared and then minus 5x. Okay, look for like terms. My like terms are x squared and negative 8x squared. Remember, the sign in front is attached to the number. So this is a 1. We're going to subtract 1 minus 8 is negative 7x squared. And then we're going to do 7x minus 5x is plus 2x. So I just cross them off as I do them. So as we get with bigger polynomials, it's going to get a little more confusing. So if you cross off what you've already added or subtracted, then you won't have any extra stuff floating around, okay? All right, so negative 7x squared plus 2x. Is that in standard form? Yes, the highest exponent is first and the next one. So yes, it's in standard form, and that is our final answer. All right, now we're getting into a little bit bigger stuff. We have trinomial plus a trinomial. We're going to do the same thing. 2x to the fourth plus 4x squared plus 2x. Drop the parentheses and just combine like terms. Okay, now this has a lot of terms, so I'm going to start with my highest exponents first. So I have 2x to the fourth plus 3x to the fourth. I'm going to add the numbers together, so 3 plus 2 is 5x to the fourth. All right, those ones are done. I don't have any x to the thirds, so I don't need to worry about those. But I do have x squareds, so 4 plus 3 is plus 7x squared. I finished those. Those are done. And then I have a 2x and a minus x. So that's going to give me plus x. Is my final answer in standard form? The highest exponent is first, x to the fourth. There's no x cubed, so we go to x squared and then x. Yes, it is in standard form. All right. Try a couple more of these. Go ahead and pause the computer, or pause the video, and try the next 3, 4, 5, and 6. So take a couple minutes to try those, and then I'm going to write out the answer for you so you can check your work when you are finished. So go ahead and pause now. Try 4, 5, and 6. Come back and check your work. Number 6 has 3 different polynomials added together. So this one's going to be really long and have lots of extra numbers. So see if you can take that challenge and get the right answer. All right, hopefully you were able to get most of those correct. Check your work. If you don't quite get it, go back and look at the video on how to do it for example 2 and maybe retry it and see if you can get to that answer. If you can't, maybe somebody in the classroom can help you out after we finish this video. All right, subtracting polynomials. When you subtract polynomials, you must distribute the negative sign. So yes, we have to distribute that negative. Then we're going to do the same thing as we did for adding the polynomials. We're going to combine the like terms. Make sure you write your final answer in standard form. All right, here we go. Here's the big part, okay? You may think that you get this, so don't skip this part. We're going to take this negative and we have to distribute it to every term inside the parentheses, which is going to change the sign of every term inside those parentheses. So we're going to drop the parentheses of the first one and rewrite it just like we did with adding. Then we're going to change negative times a negative is going to change to a positive 4x squared. Negative times a negative is going to change to a positive x. And negative times a positive is minus 3. Everything else is the same as adding. So basically, make sure you distribute that negative and change all of the signs inside the second parenthesis. You do not mess with the first parenthesis, okay? Just rewrite that one as is and then change all the signs of the second parenthesis. Now we're going to combine like terms just like we did above. Look for the highest exponent, so x squared and 4x squared. I get 5x squared. X plus x is plus 2x. And 3 minus 3 is just 0, so I don't need to rewrite that. And my answer is 5x squared plus 2x. Yes, it is in standard form because the highest exponent is first and it goes down to the lowest exponent. All right, number 2. Actually, I'm going to skip down to, no, I'm going to keep number 2. We'll try number 2. All right, I'm going to keep the first parenthesis, negative x plus 5. Distribute the negative to every term, so it's going to be minus 3x squared minus 6. Highest exponent is negative 3x squared. Next one is minus x. And then 5 minus 6 is negative 1. Is it in standard form? Yes, it is, and that is our final answer. Okay. Go ahead and pause the video and try 3, 4, 5, and 6. I'm going to write the answers in for those so you can double check your work and see if you're on the right track. So go ahead and pause now and do those 4 problems. All right, hopefully you were able to get the correct answers for each of those. These are kind of fun. Gives you kind of a little bit of a challenge sometimes, but they are actually kind of fun to put together and solve. All right, the last example is the word problem. You are enclosing a rectangular space in your backyard for your dogs to run. The length will be 3 more than 4 times the width. We have seen these before, just a little bit different type. Write a polynomial in standard form that represents the perimeter of the space. Use W to represent the width. So we're going to let W represent the width. First thing we're going to do, number 1. Oops. Can't get it to erase. Number 1, draw the picture. All right, so we need a rectangular space for our dogs to run. So here's my rectangle. It says let W represent the width. So I'm going to let W represent the width. And the length is 3 more than. More than means plus. Remember, it reverses the order when it's more than. So it's 4 times the width, which is going to be 4W plus 3. So remember, that switches the order. All right, so now we have our length and we have our width. And it says, write a polynomial that represents the perimeter. So we need what the perimeter is. The perimeter is all of the sides added together, which means that my bottom is also 4W plus 3. And the width on this side is just W. So I need to add all 4 of those up together. So we're going to have 4W plus 3 plus 4W plus 3 plus W plus W. Combine all of our like terms. So 4W plus 4W plus W plus W. 4 plus 4 is 8, plus 1 is 9, plus another 1 is 10. So the perimeter is equal to 10W, and then 3 plus 3 is 6. So 10W plus 6. There you have it. That is your answer to the word problem. So again, pretty simple. Everything we have already done. It's just putting it all together into polynomials now, instead of just looking at a couple of terms here and there. All right, well, good luck with your homework. If you have any questions, please circle them and bring them back to class, and I will be happy to go over those with you. All right, have a great day.